All right, so I'm back to working on gathering my test data set, which I was doing yesterday evening. I think I was almost finished yesterday, so today I'm just going to tidy up what I've done yesterday. So I have some birds. Yeah, I'm not too worried about birds, but it's good to have completeness. You never know what kind of birds will show up in my garden. I see these quite often. They are quite annoying birds. In fact, I nowadays get a crow, um, and it's a really strange crow because I have like a skylight in my house, which allows me to see the sunshine, and I have this crow that comes every day, and for whatever reason, it starts bickering on my skylight. I don't know what it's looking for, trying to get in or something like that, but it keeps doing it, right? And it doesn't seem to get scared, even if I try to, you know, to scare him away. He keeps coming back. So yeah, it's very odd. Anyway, so the birds I get, they're normally quite annoying. But once I had this, I had a hawk. Just he just came. It's the only time I ever saw a hawk, and he was like outside my window. In fact, just behind my computer monitor, I have a window, which is you probably have seen it in my in the stream before, and I had a hawk right in front of me, and I took a picture. I'll find it someday, and it was quite an amazing experience. So if I see a hawk in my garden, I want to know about it. Okay, so I have birds, cats. Well, you probably will think, okay, who cares? But I need to know when they come. Yeah. So I have some cats now, and then most importantly, I think the most interesting animal I get here is a fox, no doubt, right? So I just need to make sure there are foxes in my pictures. This one looks like. Can you spot the fox? I can't. So maybe I'm going to delete this one. No fox here, right? Okay, this one has fox. Fox, fox. It's a rough fox, right? It's has a very dark color, not very clean. One of the problems I have with my garden is that if I plant anything, it gets like, I don't know, it gets eaten, destroyed, or I don't know if it's the fox. But I have a big suspicion that the foxes I have in my garden, they destroy all my flowers. Yeah, okay, right. So I have foxes here. No, just make sure I don't have anything. Okay, this one looks like it has no fox. Oh, it's not very easy to see, so I'll take it away. Okay, no fox. Okay, let me just check what's happening. Because I thought okay, here's fox. Fox. I reckon it's going to be quite difficult to identify this. And I don't necessarily need to identify this as a fox, so I'm going to take this from the test data set. Okay, this is a good one to check. So Okay, this one doesn't have anything there. Another one to delete. So I'm not sure how the images should be deleted. So I'm just deleting all these pictures that have nothing in it to make sure I don't have any surprises later. So I have foxes here. Anything without a fox, I don't want. It's boring stuff, but you have to. One of the most important things you need to do in machine learning is to make sure your data is good. If you don't have good data, then your model is going to be bad. Well, bad data equals bad model. And the bad model is one where it thinks there's a fox in here because you can't see it. Um, Put it. No water. Fox. Okay, there's a fox here. Yeah, so I can delete it. So I'm left. So I'm going to review all the images to make sure I have nothing that is not a fox. Or, or anything that doesn't have a fox in it. Okay. I think this is enough for test data set. Okay, you can see another fox in the middle. This is good to make sure that if you have more than one fox, you can still recognize it. Okay, so now, okay, I'm happy. This is just a test data set. I'm not using it for training. Okay, cool. So I'm going to now put this into a zip file. So I need to download my original dataset, which is on Kaggle. And this is probably where it gets more interesting. We're actually going to work with a notebook that I showed you yesterday. If you were here, if not, just review the previous video of the stream. You'll see what I've been up to. So you can see that. So here I have datasets. So do you have the datasets in Kaggle? And then in my case, I have my own dataset, which I've created. And that dataset is here. It's on version 3. So until, oh, I need to also gather people. I'll do that later. Anyway, but until yesterday, I only had training and validation dataset. And these are pictures that I've collected from the internet. Okay, so what now I need to do, I need to download this dataset again. And I'm going to open it, and then I'm going to add the test dataset, and then I'm going to upload this again to Kaggle, and then I can use this in my notebook. I might as well start opening my code. It's getting a bit stuffy in here. I'm going to open the window. You might get some noise, but I have no choice. Really hot today. Right, so now I should have my data set almost there. Okay, so I'm going to open it now. So this is my data set, which is already on Kaggle. So I'm going to move it. Where's the other one? Test data set. This is okay. So I have to extract it first. I have some insects coming. Right, so I'll put it here. done. So our files, I didn't realize I had so many. Okay, right. So now I have my original data set here. What I need to do, I'm going to call it training and validation. And I'm going to put these 3 classes inside. Okay. And then I'm going to add another folder. And this folder will be the test data set. Yeah. So I'm going to move it here. Okay. Test. Okay. So training and validation, data that I'm going to use for the training and validation data sets. And then I have testing, which is basically only as a way to benchmark my, in this case, I want to benchmark the model against my own photos and own images from my own camera to see how well it does against that. Okay, so I'm going to zip this again. And I'm going to upload it to Kaggle. So I have okay. So now I'm going to upload this back to Kaggle. And I already have a data set, so I'm not going to create a new one. I'm just going to update the existing data set that I already have. And this is going to create a new version. And this is quite useful, right? Because, you know, over time, I'm going to be improving my data set. And you never know, you might have to want to go back to a previous version of your data set for whatever reason. You might have, I don't know, you might have lost some photos or, you know, so it's always good to go back in time. So new version. And I'm just going to upload the files. Oh, I just realized I could have done something else, which is more efficient actually. So I'm uploading again the whole data set, right? I'm going to replace everything. And I could have kept the files from the previous version of the data set, but it doesn't matter. It doesn't matter. So now this is version 4, and it's going to take a while to upload. And the nice thing is that once I have this new data set ready to go, I'll be able to see it here. Yeah. For now, this is the previous version. Once this is completely uploaded, then I'll be able to see the new version of the data set. And I can use it straight away from the notebook. And I need to change the way I need to change a little bit of the code just so that it gets the images from the new locations. Okay, so it's almost done. If you have any questions, you can always ask in the chat. I'll try to answer. Okay, so now it's almost. All right. Okay, so now we have the new data set, and I'm going to create it. It takes a bit of time to process the new data set, but I think it's in practice it's actually very quick. It tells me it's 10 minutes, but I think it would take less than that. So let me just. Okay. All right. So yeah, I see that your message now. Yeah. So what I'm actually trying to do here is I'm trying to gather a data set for training a machine learning model. In this case, this is a machine learning model that I'm basically I'm doing custom training on it. Basically, I'm taking a mobile net model which has been trained on the ImageNet images, which is about it's a data set that's used. It's quite popular. It has about 1,000 different classes of objects that it can identify. In my case, I have a camera that I'm using pointing to my back garden. I only need to identify 4 or 5 classes. So what I'm doing is I'm using transfer learning to take the existing model that was trained by Google. I'm providing my own images and I'm training that model so it can learn from basically we don't have to start from scratch. It will learn how to identify the classes that they are in that I want. They basically it will learn from the images I give it. It will learn how to identify the new types of classes. So in this case, it's a fox, a cat, and what else? Birds. Yeah, I'm trying to. So I only want to distinguish, 4 types at least, 5. So foxes, cats, birds, people, and also nothing, right? So if there's nothing in my garden, I want to also have that as a classification. Okay, so I've just created a new version of my data set, which has images, my own images, right? And I have version 4 here. So I have a training and validation, and this data set here is used to train the machine learning model. And then this testing data set, I don't use for training. I only use at the end for benchmarking the model. In this case, I'm using pictures shared from my own garden. Yeah. And the goal is to benchmark, because at the end of the day, I'm using this machine learning model in my own setting, right? Which has yeah, I need to make sure it works for that. But I want to keep the model general. So that's why I'm using for the validation and training data sets, I'm using pictures from the internet with very random backgrounds. So these are not my images. They were, so I took some other Kaggle data sets and I added my own images on top. I hope that clarifies. Okay, so now I'm going to the code and I should be able to see the new data set there. Now it's still seeing the version 3. So I'm going to remove it. Actually check for updates. Yeah, so I'm updating now my dataset from version 3 to version 4. And I can see the new images here. Okay, so I need to modify the existing code because it makes assumptions where the images are, and these have changed. So I need to copy. Okay, so it needs to do some initial setup. So in general, right, when you just, there is a TensorFlow website when you where you can download lots of machine learning models, right? Well, TensorFlow Hub is a good one to start with. You can, there's lots of different models here, and you can pick the ones that maybe fit your use case. But the problem with, I mean, these models will work great, right? But they've been trained on specific tasks. They are probably not an exact match of what you want to do with them. So you need to always do some kind of transfer learning. Yeah, which is basically it's just retraining the model to do something else, but without losing all that he has learned in the past because it can be useful. Okay, so now did I need to update this folder. Oops. Training. I need to make sure I run all the blocks at the top, except these two. These two are not needed because we are already on Kaggle and we don't need to download the training data set because Kaggle automatically downloads it for us. But if I was running this notebook on Google Colab, I would need these two cells to be run. For now, I just need to make sure the imports are run, and I should be able to execute this now. And this method here, what it does, it basically just takes a sample number of pictures from each folder. So I know exactly how many images I'm taking. So here I can see I have 500 images of birds, 500 images of cats, and almost 500 images of foxes. Then you can see some examples of images that we have in our dataset. It's a very unusual fox. It's not nothing like what I have in my garden, but never mind. So I have here bird. Okay, cats. And now this is where we start preparing the model to be trained, loading images for the training data set. So this class here in TensorFlow, this method is actually used quite often. It does a lot of things that we always want to do in machine learning, and especially when we are working with images. Basically, it loads images with a batch size. So basically, batch size means I can read 32 images at once into memory, so they can be processed by the model. Then I can resize the images already to the image size I want it to be resized to. In this case, this image is I'm resizing to 224 square because that's optimized for ImageNet, which is the not ImageNet for ImageNet. I think that's the model I'm using somewhere here. And then you can also do cropping, right? You know, when you resize, you don't want to always distort the image. Okay, here we can see an overview of all the images that we have, like just a sample. And okay, so this tells me what are the shapes. In this case, we have it's a batch, right? So a batch of 32 images, and each image is 224 pixel squares. 3 is the number of channels, right? Because RGB, right? So red, green, and blue. Right. So let's do this. So training and validation, yeah. So for now, we are only using this folder in the dataset, and we're using MobileNet. Now, so here you can see there's some image augmentation. We're doing image augmentation because just to increase the variety of, well, we only have 500 images, right, of each class. With image augmentation, we can increase the number of images that we have. It's a bit artificial, but one of the goals is not just to have more images, is to make sure that we confuse the model a little bit so it doesn't learn things that it's not supposed to learn. Actually, I'm going to be improving this image augmentation because in my garden I have different lighting conditions, and I think the images that I've been using, they all have very good lighting conditions, which is not a realistic scenario most of the times. So we have, okay, here we are building the model, the different layers. So we are doing transfer learning, right? So we take the top, basically we take the whole MobileNet v2 model, which has already been trained. on like hundreds of thousands of images, right? And it is able to identify 1,000 different classes. Okay. In this case, we don't want the to identify 1,000 classes. We only want to identify, for now, only three, right? But we're going to identify five at least. So we only want to identify a very limited number of classes. In that case, what we do, we use the bottleneck of this model. So we take the last layer away, right? So we throw away the last layer, and that's why you have here include top equal to false, which means the last layer, which is the layer that of neurons that actually says, okay, for these 1,000 different classes, what is the probability of this image being to that class? So that layer is gone, and we are going to replace it with our own layers. Okay. And here you can see this one is a global average pooling layer, and basically this is just reducing. Okay, because the model itself, you can see the shape here, it can, okay, without the top layer, for a single image it can calculate 1,280 features. Okay, and then we need to reduce this number of features to 3 neurons, right? And the 3 neurons are cat, fox, and bird. Okay, and before we do that, we use global average pooling. Okay, and that reduces. Okay, so you can see now we have only, we have global average pooling. Now this is where we build the whole model, right? So we have the image augmentation here before we do anything else. Pre-process, this is the important one. This pre-process is because image, the model we're using, which is MobileNet, expects, instead of having, each pixel goes from 0 to 255. Okay, the machine learned model is not expecting those numbers. It expects numbers between -1 and 1. Okay, that's actually quite rare. Normally you would find that the model will want numbers normalized between 0 and 1, but in this case it's -1 to 1. Okay, so that's why we're doing a pre-processing here. This method, it's defined here. It's actually, we are already using a TensorFlow .keras application. This is like a pre-existing method in the TensorFlow library. But what it does is actually dividing this by, so it divides the number of pixels, 250. For example, I said if you have one pixel with value 255, which is the maximum, it will divide it by 127. Yeah, something like that. Yeah. So we have that, the pre-processing. Okay, then we call the actual model, the ImageNet model. We make sure that during training we are not changing any of the weights in this model. So that's why we have training equal to false here, because we don't want to train those weights. Those weights, they should stay the same because they've already been optimized with thousands of steps and thousands of times, using thousands of images. So it's already as good as it can get. Okay, we don't want to train that, so we don't want to touch it. The only thing we want to touch is anything after that. So the global average pooling, what comes after that. Yeah, we have here this, I've explained this yesterday, but And then we have the dropout. Dropout is a regularization. We're trying to confuse the model as well to make sure that it doesn't learn what it shouldn't learn. And finally, we should add some neurons. The dense layer should be somewhere. That's it. Yeah, the dense layer is in the prediction layer, right? So the prediction layer is here. Okay, so we are adding 3 neurons. So I'm going to run this. Now we're going to be training the model using the training and the validation data sets. For now, just some, these cells actually haven't trained the model yet. What we are just doing some debugging. And here, actually what I'm doing, we're not training anything. We're just evaluating this model without changing anything. Basically, we are not actually even, it has default weights for the, it's going to have a terrible result, right? So it's really terrible because we haven't trained the model yet. So you can see the accuracy is like, is 40%, right? It's it's terrible right now, and that's what we expect. Now we're going to train it, and after this, it should be pretty good. Okay, so 10 epochs, it should be enough. So it goes through all the, in each epoch, it goes through the whole set of images, right? And it's divided. You can see there's like 37 steps in each epoch. That's because that's how it divides the total number of images by the batch size, and it gives you this number. Then we have, you probably notice a number, the learning rate. We've set a learning rate. The learning rate is how fast we update the weights. How, each time there is at the end of each epoch. Okay, so we've completed the training. So let's see how it does. In this case, I'm still using the validation data set. So it should be, it should do pretty well actually. So you can see this, and I can explain some of this debug in a second, right? But you can see here, these are the images in the validation data set. Okay. And then what you see here, this is the prediction. Okay. This is a cat. We can tell, we can all agree on that, I think. Then we have a bird, a fox, cat, bird, cat, bird, bird, cat, bird. Yeah, it seems to be pretty good actually, right? I don't see anything wrong. Even this fox, you don't even fully see it. It can guess it's a fox, which is pretty awesome. Okay, right, but obviously this is using the validation dataset only. And what I have here, this is some debug that I added in this code so you understand it. Okay. So what we are doing here, we are getting one batch of images from the validation dataset, and then we're getting the image batch and the label batch. So the label batch is basically the actual labels. Yeah, these are not predictions, these are the labels. To get the predictions, what we do, we call the model which has been trained, right? And we pass in the image batch from the validation data set. Okay. And you can see that the predictions we get, they look like this. Okay. This is basically an array of elements, and each element here is three numbers, right? And this correspond to the number of neurons that we've created in a dense layer. And each neuron represents a class, you know cat, dog, no, cat, fox, and bird. Okay, it's in order as well, right? So you can see here, this is the order. So the first number is the bird, how likely is going to be a bird. The second number is how likely it's going to be a cat. And then the third number is how likely it's going to be a fox. Okay, the assumption here is that each image that we are seeing doesn't have both both classes, right? Hopefully we don't have anything with a cat and a fox, but it's possible, right? Okay, then we have this function here, tf.math.argmax, which receives the whole array. Okay, and then for each element it finds which element is the highest, right? Okay, in this case it finds that this is the highest number. Okay, and then it will return the index of the element which is highest. Okay, so 0, 1, 2, so 1. So the first one is going to be 1, then the second one is the highest, this is the first element, and so on. Okay, so these are indices, right? And this corresponds to this array. So the first one, for example, is going to be a cat, the second one is going to be a bird, and so on, because we have indices, right? So we have transformed that list of indices, which we get here, right? And we transform that to a list of classes, which you can see here. Okay, and then using matplotlib, we are just taking all the images from the image batch that we had at the beginning, and we're just printing the score, the predicted class name, and that's how we get these results. What I'm going to do now, I'm going to create a new cell, and I'm going to do the same that we have done here with the validation dataset. I'm going to do that against the training. I'm going to do that against the test dataset. Okay, so I'm just going to copy and paste code because it's more efficient. So I'm going to copy the validation dataset. I'm going to call it test dataset. And I'm going to get the images from the tester, which I'm going to initialize. So tester is equal to this directory here. Okay, so I just saw your question. 1 second. So you ask why the axis is -1. Um, Okay, so let's go into the TensorFlow function. So this is a function, and there is a value of here of axis. So basically, by default is none. You can see examples here of how you use this function, right? Oops, did I do? And you can see, okay, tf math the argmax of, so we have here an array, right? And if we call the function tf.math.argmax on this, it returns, so the highest number is 30, so 0, 1, 2. Yeah, 2. Okay. And I think the easiest way to actually test this, I'm going to play a little bit. It's hard to answer this question without really showing you how it actually works. So I'm going to copy this. And we'll see the effect that the -1 has. Oh, sorry, I was on mute. Sorry, sorry. Um, yeah, can you hear me now? Right. So I I was just saying, right, that the results that I see here, these are images from my garden, right? And these images are not are completely different from these ones, right? You can see here it's quite obvious what, for example, this is a big bird, right? But here you have like it's much harder to. It's different. Anyway, the model should be able to learn this quite well, but because we haven't actually trained on these images, it doesn't have a clue what they are, right? Everything is a cat, so it's pretty horrible. But it's not surprising. I wasn't really expecting much, and yeah, I'm glad that I didn't expect much because then I would have been disappointed. So the few things I can do to improve these results. First of all, I could actually decide to use my own images for training, which I think it might make sense, right? But I would want to avoid that first. I wanted to actually try first some more augmentation. I'm not going to do that today, but in TensorFlow you can do different types of augmentation. So I can show you an example. We're already doing random rotations and flips, and I should be able to see more examples. We can also do change the colors of the image. Instead we can convert it to grayscale. We can also adjust the image brightness, which is useful if you want to simulate maybe different lighting conditions. But I was hoping to have something which allowed me to zoom out or something, or make things a bit smaller. But I don't think that that's out of the box available. So I need to think about how I'm going to do the next step, right? Because right now this model is no good for my garden. Yeah, it's going to do terrible if I do this, if I use this in my garden. Cat, 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 cat. Um, I wonder if there's something I miss here. Maybe I missed something here. Oh, I know what. I think I've forgotten to do something quite important. Is it the normalization? I haven't done it. The thing I was talking about before. Shouldn't have to do it now. It's already a part of the model anyway. So the model itself will normalize the images which I provide. Okay. Yeah, it's bad. So I just need to think of another approach for training this model. If you have no questions, I'm going to finish the stream now, and I'll continue this some other day, maybe tomorrow. Yeah. All right. Thank you so much for you. Yeah. I'll be all for now, and I'll see you again soon. Happy coding.